friends, Unit 1, Day 6. Now we're getting to solving equations that are in a quadratic form. Now, they're not in the quadratic form, they're in a quadratic form. So one of the things that I like to do is I like to look at things and say, okay, how can I solve this by factoring? How can I solve this by ways that I already know? One of the big ideas of math is to take a problem that maybe looks a little bit complex and then maybe breaking it down into pieces that you might be able to understand or work with. One of the ways that math allows us to do that is by substituting ideas, concepts, values, things in for something else. And one of the biggest things that students have frustrations with, they share with me, is the idea with use substitution. And the idea with use substitution is you, the word you, are substituting in something for something a little bit more complex. And one of the ways that we use substitution is to say, okay, we're going to take this a little bit more abstract or idea that we can't really work with, and we're going to turn it into something that we can work with that we already know by substituting in something else. And when in doubt, substitute the letter U. Why? Because it's you, Y-O-U, that are substituting. So let's go ahead and look at this idea here. So here we have 12 x to the fourth minus 11x squared plus 2. Let's think about this for a second. This looks really close to a quadratic. The only problem is that it's not a quadratic. It's x to the fourth, not x squared. So what I'm going to do is I'm going to substitute. Instead of using x, again, I want this to be x squared. So I'm going to say, okay, instead of it being x to the fourth, I'm going to say u is now x squared. So anytime that I want this to work out using a quadratic, I'm going to use a u. Now think about this for a second. If I have 12u here, and how would I want this to be to the fourth? Well, I would have to have it squared. Again, if I take x squared squared, that's x to the fourth. And kind of pause the video and wrap your mind around that this is actually valid. And if I continue that, this is just 11u. Remember, u is x squared, so this is just taking the place of x squared. And then plus 2 equals 0. Now I can focus on factoring this. And if I factor, let's think, what are the factors of 12? Well, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factors of 2 are going to be 1 and 2. So I know for this here, my last two terms are going to be a 1 and a 2. I just need to make sure I have the right placement with things. Okay, with this being a plus sign here, I know it's going to be minus minus, so I know I'm going to have a minus 1 and a minus 2. So let's see. If I do 3 and 4, does that work? 4 and 2, yeah, that'll work definitely. So I'm going to do a 4u here and a 3u here. So let's see, 4u is negative 8. Yep, that'll work. All right. So now I can set both of these equal to 0 and then solve. So I'm going to have 4u minus 1 equaling 0. And then a 3u minus 2 equaling 0. So 4u minus 1, so let's see, I'm going to add 1 on both sides. Let's go 4u equals 1. Divide by 4, divide by 4. So I have, for this side, I have u equals 1/4. Yeah, let's go ahead and do this right here. And then here, add 2 on both sides. 3u equals 2. Divide by 3. So I have u equals 2/3. Okay. A lot of students want to stop here. Remember, we didn't find what x equals, we found what u equals. We know that we said that u is x squared. So now at this point, we're going to take this idea of u, and we're going to say, okay, well now we're going to have x squared equaling 1/4, and x squared equaling 2/3. Now, if I wanted to get rid of an x squared, and simplify it down to just an x, I need to take the square root of both sides. Square root, plus minus. So I have x equals plus or minus the square root of 1 over 4, which is 1/2. And then the same thing with this side. Square root, plus minus. And so I have x equals plus or minus the square root of 2/3. Now, square root of 2/3, we need to go ahead and simplify so that we rationalize. We don't have a square root of 3 in the denominator. So we're going to do that by saying, all right, we're going to multiply through by radical 3 over radical 3. So again, this is the same as square root of 2, square root of 3, and I'm multiplying by the convenient form of 1. This is where students make mistakes, because back in that other problem, we were multiplying through to get rid of the denominator. Here we're rationalizing the denominator, convenient form of 1, so just keep that in mind. So this, when I simplify through, this is going to be plus or minus the square root of 6 over 3. So my four possible solution sets are here and here. I want to take a moment now to talk about the fundamental theorem of algebra. The fundamental theorem of algebra says whatever the highest power degree of exponent is, that's how many answers you should expect to see. With this problem, we started out with x to the fourth. I should expect to see up to 4 real solutions. With complex numbers, you will see 4 solutions. So here I have plus or minus square root of, oh, I circled the wrong thing. Oh, I'm so sorry. Should have caught that. My apologies. Here, 1/2. So here I have plus or minus 1/2, so that's 2 solutions, positive 1/2 and negative 1/2. And then here, x equals plus or minus square root of 6/3. Those are 2 other solutions. Join me in the next video as I continue on with the examples.